So Dr. Scott Fisher is a faculty member at the University of Oregon's Department of Physics, where he teaches introductory level astronomy courses and serves as the director of the undergraduate studies for the department. Scott is the director of the Pine Mountain Observatory, which is located about 30 miles east of Bend, in an area which is some of the darkest skies left in the U.S. Scott previously worked at the National Science Foundation in Washington, D.C., where he was responsible for selecting and funding astronomy programs across the United States. Before his time in Washington, Scott was based in Hilo, Hawaii, where he worked as a staff scientist of the Gemini Observatory. At Gemini, he worked as an instrument scientist and as a member of the Gemini outreach team. So this evening, I'd like to welcome Dr. Scott.
It's always a little embarrassing standing here. But thank you, Sean, for that wonderful introduction. And for better or for worse, you're going to get another version of that in about 2 minutes. But hello, everybody. Thanks for coming out. This is a good crowd. I mean, look at all y'all came out here tonight. There's just a few seats left. And I was speaking to my a colleague, Carrie, who was back in the back, and I realized it has been 8 years since I spoke here last. And so back in the before days, we came in and had a wonderful event, and so I got in touch with Carrie a couple months ago, and here we get to come back to Pineville for an evening. And as Sean said, I got what I think is a pretty interesting talk. I took 2 or 3 different topics and smushed them together into one talk. So seatbelts on and tray tables up. You know, these flights are about to take off. I don't know where the heck we're going to end, but we're going somewhere. And I'm going to give you a warning right before I start. All of these slides I'm about to show you come from my Astro 101 class. So you're kind of getting a little bit of a dose of what it's like. Not the first day, you know, I took slides from all along the term and smushed them together here into this talk. But this is to inspire you to come and sit in my class someday and we'll teach you a little astronomy. So look, I like to start off my talk with what I call picture of the day. And it's mostly, I tell the students it's for them, but it's mostly for me to kind of get me warmed up. And this is what I picked today, because this is a photograph of that's middle sister right there, and there's south sister right there. And look at that Milky Way just shooting up right out of middle sister, an eruption of stars. There, that's not have any other eruptions, but you know, an eruption of stars looks just fine coming up out of there. And you can't see the gentleman's name, it's sort of down here, but this is a professional photographer who hiked to, you know, almost to the summit of North Sister, and then sat there and until the Milky Way came, rotated over, and got this beautiful picture for us. And the golf clap, thank you very much for him doing that. I think it was his 3rd trip up. He's on the little webpage he wrote, he's like, well, I went up twice and got clouded out, but then a 3rd time, I was going for it. And so look, there's a lot going on in this picture. There's not only the beautiful mountains and the glacier, by the way, there's a meteor that he happened to catch when he was taking the picture. And you can't read it super well, but he also has a version that has, oh, you know, again, middle sister, south sister. There's my bachelor back in the background. There's Ben. But I wanted to show you a little, maybe a naughty part of the photograph. And that's the glow of Eugene from North Sister, 60 miles away. And by the way, there's that little big, what's that? Oh, Portland, yeah, okay. There's Portland, 100 miles away, and that's what we call the light dome. You know, the dome that comes from the city. And let me say something very carefully right now. Astronomers are not against safety. We like safety. We like lighted paths. We like lights on the highway, turns out. But don't shine them up in the sky, shine them down. And, you know, so I'm part of a project here in Central Oregon where we're working to preserve our beautiful dark skies. And we just had a fun chat, Sean and I standing back there. Pineville Reservoir, right? That way we have a camera out at the reservoir, and for 2 years we've been taking movies of the sky every night and also measuring the brightness of the sky. And Pineville Reservoir is the 3rd or 4th darkest place in all of Oregon, well, Central Oregon, where I think we have, what, 20 of those cameras around? Quite a few. Yeah, would you say? Quite a few, maybe 20 of these cameras, including one up at Pine Mountain. and Prineville Reservoir and Pine Mountain, you guys are as dark here in the reservoir as we are up at the observatory. And by the way, anybody want to guess where might be the darkest place in all of Oregon? It's a hard one. Oh, some compared to Steens, I'm going to give you a gold to bronze star. Albert, the Albert Desert is the darkest. And then the second darkest is, I think, Summer Lake, down in the kind of Summer Lake here, where you might imagine where no people. So anywho, the idea is that there's a group of us right now that are working to help preserve the dark skies, and the way we're doing it is we like to say, look, the dark sky is part of the environment just like the rivers and the mountains and the desert that we have. It's just part of the whole, kind of a holistic view. And this is just, again, a picture that I like to show because it's a beautiful astronomy picture, but it's a nice segue into just talking gently about this idea of what we call light pollution. So Tim, or whatever your name was, good job getting up there to the top of the North Sister for us. That's not the type of Tim that I like. So another thing to help me get warmed up is the story of our lecture that's coming through here. And tonight I want to cover a couple of my favorite topics. A cosmic perspective check. I mean, it's in the title, so we might as well talk about that. Then my third favorite topic, planets and exoplanets. So we get in my second favorite topic. Oh, you think I'm joking? And then look, and then I'm ready. You bring it along the way here. If y'all are thinking about a question, I'm feeling froggy tonight, so I'm going to do some Q&A on top of that. But again, this is a little bit more for me than for you guys. But here's a slide that I showed the students. Pretty much on the first or second day of class, when I say, look, students, I've got you for 10 weeks, and you're going to have to listen to me lecture to you 28 times in those 10 weeks. And right here on day number 1, I'm going to tell you, what do I want you to get out of this class? And I really sort of believe this, oh, science is cool, and any of you all that are willing to come down and hear me talk about it, obviously, you all realize that. But you know what? For some folks, it kind of gets squeaked out of us. It gets scared out of us a little bit. And by the way, what does middle school often will scare it out of you? But I'm convinced that we are all astronomers. Every human being, every person in this room is an astronomer, because astronomy is embedded very deeply in our lives. So deeply that we don't even think about it too much anymore. I mean, look, when are we asleep and when are we active? Well, when the sun's in the sky. And what determines when the sun is in the sky? The rotation of the Earth around its axis. By the way, how do we tell time? It turns out, until we got fancy schmancy things like atomic clocks, our time was based on the sun. Right? By the way, all the way back to sundials, think about that 5,000 or 6,000 years ago. But a lot of the way that we have set up the systems that allow us to tell time were astronomical when they started. And then also your birthday. And as I look around this room, I say we are all of a certain age, I can see. We've all made a few orbits around the sun. But look, that's it. I mean, that's how old you are is literally how many times you've rode this beautiful blue rock that we live on around the sun. And we don't think about that much, but it turns out that's it. And then I sort of say, and look at having a moment out under the stars. And I tell the students, I'm like, this is just day 1, but I'm going to tell you this little secret. I'm going to pinky swear on the secrecy. I'm like, you learn some astronomy this term, and then one of your secret homeworks is after the term, you find yourself a significant other, that's the hard part, but find a significant other, a blanket and a cooler with some beverages of your choice. And you take your significant other and that blanket and the cooler out under a dark sky and share the astronomy knowledge that you learned in Astro 101. And by this time you see some of them are like, and I'm like, you do it right, you might get a smooch. And the point is that astronomy will pay you back in wonderful ways if you take advantage of the knowledge that you learn. And again, but I just think this is something that we all identify with. I bet you every single one of us in this room during our lives sometimes has walked outside and just had a moment where we looked up in the sky and just that moment of awe, in the most truest sense of the word. It's truly awe-inspiring, especially here where we have the dark skies and all the beautiful views. And so I did. You're going to learn some astronomy tonight. So put it to good use later on. That's all I'm saying. All right, let's see. Oh, I forgot this one was in here. Oh, and then this is the last slide I showed on the first day. And I say, ultimately, in the next 10 weeks, if I can give you a scientific view of the universe that you live in, I win. I win the class. You know, you guys win because you get some knowledge, but I win because I got to transfer that knowledge to you. And then what they don't know is throughout the entire 10 weeks of the class, I keep showing them this same photograph. At the first day, we don't know anything about it. By the end of the term, we've talked about a lot of the things that you're seeing, and then it's on their final exam they have to describe it. Don't you be telling the student, I got a granddaughter in my class, I don't want you thinking out what's going on with the final exam. But ultimately, the idea is can I take some of the knowledge that I have and share it with my class, but also folks like you know, in an informal setting. Let's look at some cool pictures, and let's talk about me. I'll go fast. So look, again, pretty much the first day of class, I'm standing up in front. Look, you all, 4, 8, 12, 16, about 40 people in here. Well done. You know, my last class, 260. So you all are looking awful friendly right now. You know, a small group, small bunch. So here I am in this massive auditorium, and I'm just some guy standing in front of them. And so I at least try to say, let me tell you a little bit about my background. And one of the points that I made very early on is that I was them some number of years ago. That number is now 30. Yeah, so it keeps going up, that number. But I was a state school boy. I went to a community college where I got a 2-year degree, and then I spent a year studying abroad. And again, given this wonderful crowd that we have tonight, in a country that does not even exist any longer, I spent a year in West Germany. Anybody remember West Germany in here? Yeah. You know who doesn't remember? The students, the college. What? There was a country that doesn't? Yeah, okay. So here's the students. So I went to West Germany for a while and came back and finished my college degrees at the University of Florida, which is an exact analog of UO, a big flagship state school. And I just think it's, I'm going to make a point to say, I love being at UO. I love our fine rectangular state of Oregon. You will drag me out of here by my fingernails. But I want to make sure to tell the students that there's a path from that chair to this lectern if they want to take it. You know, that sort of thing. And Sean, you did such a good job in introducing me. I'm not going to talk about that stuff. What I am going to show you. I'm not bad if there's any beavers in the room. Good. I'm good with y'all. I'm good with y'all. We can bond in our mutual dislike of Washington Huskies, right? Yeah. I like you guys. Okay, so me and the duck, we're pals, and our relationship has deepened over the years, as you can see. And this was a couple years ago where I got invited to be a guest coach for our football team. And I got to spend all day with the team at a home game, and part of the gig is I got to go to the football game and watch it from the field. Not up here in the stands with the commoners. No, I'm only picking. It turns out that's the student section. And so it was actually kind of cute. I was standing out there, a couple of students like, Dr. Fisher, Dr. Fisher. I was like, oh, hello up there. Yeah, but so the point being ultimately is that I'm very, very proud to have UO on my resume, and I'm a proud duck. I'm a gator and a duck these days. So Sean mentioned I actually had a career before I came here, and for about 15 years before I came to UO, I was a professional astronomer. And during that time, I worked in an observatory called the Gemini Observatory. 2 telescopes, one out in Hawaii and one down in Chile, down in the southern hemisphere. By the way, that way the astronomers, we can see the whole sky, right? We can see the northern and the southern hemisphere. And really the key is that I got to do a lot of observing with the largest telescopes in the world. And again, I'm proud of this stuff and like to share it with you. But lots and lots, I have about 500 nights of observing on telescopes in the top 5 in size. And by the way, I'm going to show you a monster, one of these monster telescopes here in a moment to give you a feel for it. But then I did something real right before I came to UO. I went to Washington, D.C. and had a 3-year position there where I worked for this called the National Science Foundation, and I got to fund astronomy. And boy, let me tell you, you want to be popular? Hand out $15 million a year in grant money. Everybody wants a piece of Dr. Fisher at that time. And so, but it was very interesting. Almost all of the programs that I funded had a strong educational component. How do we get young women involved in science? How can we provide scholarships for students to do this, this more advanced research and things like that? So I got a lot of experience working with students, and then it was like, well, wait a second, I might want to give the professor thing a try. And it just happened that the universe smiled on me, and UO had a position open when I was headed back to Hawaii, but I never made it back to Hawaii. I veered up to the north and landed in Eugene, and that was in 2012. And now the mold has grown on me, just like everybody else over there, and now I'm stuck. In a good way. So, and then fun for Central Oregon, I'm also the director of our observatory, which again is out in Bend, and I'm inviting all there shortly, so hang on. I don't know. Here's the telescope I used to work at. That's the Gemini Observatory up on top of a mountain called Mauna Kea out in Hawaii. And oh, look at that blue sky. We used to call that Mauna Kea blue. Now I call it Pine Mountain blue. But back in the day, it was Mauna Kea blue. And you knew if you were driving up the mountain and in the SUV and you saw the sky look like that, you were getting excited because you knew it was going to be a good night. Perfectly clear, often extremely cold, but you knew that you were going to get some data. And this particular telescope has what are called vent gates. And those gates actually open and close. And at the moment we have them open because at the beginning of the night, we like to let the air flow through the dome to equilibrate the temperature. You want the temperature of the air inside the dome at the same temperature as the dome outside the dome. There are things that astronomers really hate. Daytime. Not all astronomers, solar astronomers like the day. Clouds, we can all agree. Clouds suck, just broadly, across the board. But you know what else we dislike? Distortion. And we really dislike when little heat waves or little breezes distort the images we're trying to take. So look, we use these vent gates as a way to minimize distortion. But I also want to show you this picture because one of my colleagues is hiding, not hiding, but she's standing in that picture right now. And I promise, full-size human being, like that tall, she's around here somewhere. I'm not going to tease you too much. Ah, there she is. Hi, Naivy. So there's Naivy. Just again to give you a sense of scale about this monster machine. By the way, there she is. Somebody saw her. I saw it up here. So there she is, standing right there. And again, and by the way, here's the telescope that's inside. In this picture, the telescope is pointing straight up. And sort of to give you just sort of a sense of feel of what the big machines, the biggest machines of astronomy are. And here's a computer. That's a computer drawing of the telescope. And the two things that I would ask you really is the telescope is 72 feet tall. If you think 72 feet, think of a nice tall fir tree, or ponderosa pine over here. Think of a nice tall ponderosa pine. That's about the size, how tall that telescope is. And then there's something pretty amazing. The mirror, by the way, this is a picture of the primary mirror. That is 27 feet in diameter. Oh, hold your arms out. Look, that mirror it would fit in this room, but not by much. Think of a circular piece of glass that's about 27 feet across. I bet it's bigger than the mirror you've got in your bathroom at home. I'm just saying, unless you've got a monster mansion. And the whole telescope weighs 342 tons. And by the way, you know who is the scariest audience? Fourth graders. Because they will ask you questions like this. I showed a bunch of kids this slide, and the little guy put his hand up, and he was just like, "If you don't call on me, I will explode right this second." And he's like, "Dr. Fisher, Mister." And I'm like, "Yes, little kid." And he goes, "Is that a lot?" And I said, "Yeah, that's a lot." And he's like, "Does that weigh more than my uncle's truck?" And I was like, "Yeah." And he was like, his eyes were like as big as something. He could not imagine that anything was heavier than his uncle's truck. And we then went and calculated it, and by the way, this is about 145 Ford Explorers. Just to let you know. So, and then any of you that have been on the UO campus, it turns out there's a building that has a beautiful atrium in there, and that telescope would just barely fit inside the atrium of this big building. Let's go from computer picture to actual. When I stand there for a moment, and you'll notice that this was now 15 years ago, and look at that strong forehead. I'm just saying. So look, there's me standing right in front of Gemini. And in this, first of all, everything that's blue is the telescope. And in this particular picture, my buddy Simon that I was working with, I asked him to tip the telescope over, so the telescope is tipped over so that it's pointing out of the frame. And there's the mirror. So by the way, I'm about 6'4", and so you think, 3 of me and then some will fit across the diameter of that mirror. And I think, again, it's just a moment where like, wait, and they're like, well, Fisher, where do you look? Where do you put your eye? And I'm like, well, it turns out you don't put your eye. No human being has ever looked through that telescope. But at least one human being has climbed up the rear end of the telescope to try. That was me. Don't tell anybody in Gemini. But I could not stand that no human had ever looked through there. So I literally climbed up in the telescope one time with a little piece of white paper and tried to hold the white paper. And I'm like, that's close. It didn't work. But how you actually observe with the telescope is sitting in a lovely warm control room, which is a couple stories underneath the telescope. And there to operate that big telescope, well, let's see, you need 1, 2, 3, 4, 5, 6, 7 monitors, a laptop, 2 keyboards, 2 mice, 2 ink pens, and your trusty calculator. Can't go observe without your calculator, all the other nerds make fun of you. But that is actually, when I got to go to work and actually work at the telescope, that's what I did. I got to sit there in front of the screen. And by the way, it's incredibly intimidating at first, as you might imagine. It's just like 7 monitors, but you do it a few times, and like click, 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 you're clicking around like you know what you're doing. But the idea is that all of the big telescopes in the world, no more eyeball observing. They all have digital cameras, pretty much like we have in our phones, but super duper versions of the same technology. But that's what a modern astronomer does most of the time when they're observing. They get to sit, and by the way, it's quite humane. There was a coffee machine, and then a microwave, and then you could cook popcorn and have a little snack in the middle of the night. So it's really quite posh observing at these big telescopes. But I don't think there's 2 or 3 more pictures of me. You can't stand it. All right, that's it. Ooh, astronomy stuff. You ready? You will notice on this beautiful slide a computer rendering, not real pictures. This is a computer models of the 8 major planets in the solar system. I'm getting some dagger eyes from the back of the room. I will make one quick comment. Pluto is still out there. Pluto is doing fine. Orbiting around, living its best life. Just got visited by a spacecraft, 5 or 6 years ago, but we did reclassify it. It's now a dwarf planet. And maybe I'll give you the full spiel later if I'm feeling. But let me talk about the scale of the solar system for a second. So the 8 major planets, we got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those 2 might be backwards. No, that's Neptune, Uranus and Neptune. The neat thing about this graphic is the relative size of the planets is correct. They're just computer drawings, they're just computer models, but that is truly our beautiful little Earth would fit just about perfect inside the red spot on Jupiter. We don't want to, since that's an Earth-sized hurricane, so let's not do that. But just to give us a sense of scale, the Earth would fit just about perfectly in there. And by the way, about 8 Earths would fit across the diameter of Jupiter. Y'all remember from geometry, it's a circle. Take a line right through the middle of a circle is called the diameter, and about 8 Earths would fit side by side right across Jupiter. And you're like, gee, Fisher, pretty impressive. Like, yeah, people look there. That's big. Yeah, we're forgetting, we didn't include something here in this particular graphic. The big mama of the entire solar system, the sun. And you bring it up, get up there, you bang! That's the exact same models, by the way, but now with the sun included. And there's Earth. And by the way, our little moon right next to it. And this is what I tell the students, and for you all students, but students for an evening, this is your first perspective check of the term. And I will go one level deeper. 109 Earths will fit across the diameter of the sun. Has anybody in this room ever thought of 109 Earths before? You? Oh, he's special. We'll introduce him later. Yeah, 109 Earths. That's a crazy proposition. But I always, when I'm right here, I like to think of making a beautiful beaded necklace of 109 beautiful little blue Earths. And you sort of hang it around the neck of the sun, and 109 of them would fit right across the diameter of the sun. And I think that's something that it takes a little while for this to sort of sink in. By the way, don't look at the sun. Ladies and gentlemen, you all have a few years under your belts now. You know darn well. Don't look at the sun. One of the worst headlines I can think of. 2 Fisher's astronomy students blinded. They looked at the sun. No, don't look at the sun. But, next time you're at the coast, maybe a sunset, the sun's real low in the sky. Don't look at the sun. Take a glance. Don't look. Take a glance. Just a quick one. When you see the sun like this in the sky, I want you to think of my lovely smiling face right now and the fact that 109 of our planets will fit across the diameter of that thing. And it's one of those things, again, it takes 2 or 3 times for this to really sink in. But it's something that helps ground us in a very real way. And I have a funny analogy to make for you. So kind of keep that in mind. Let's see. Oh, it never rains here. I've learned that since I've been here. So, like I said a little bit earlier, I'm 6'4", so keep that in mind right now. But this is an image of Watson Stadium that I lifted from Google Earth. Has anybody seen the program Google Earth before? Yes. And by the way, what's the first thing that you look at your house? Of course, my car was in the driveway. I could see it. So, but then, I was just surfing around Eugene one night and I came across Watson. And by the way, there's a way that you can measure distances. And you click and drag a little button and it tells you how big things are. From right here, this scoreboard, right across the diameter of Watson Stadium, right here to right there, 665 feet. Anybody want to take a stab at what 6'4" times 109 is? Really close to 665 feet. 109 of me, sidebar, if there was 109 of me, we would band together and we would rule this rock. Benevolently, okay, yeah, for sure. But if you took 109 of me and stacked them head to toe, I would fit almost perfectly across Watson Stadium. And so the point for the students is, you compared to a stadium is the same as the Earth compared to the sun. And I actually tell them, look, the next time and by the way, this also holds roughly for the Moda Center, or maybe not a high school stadium, but the McKnight Arena, or where the Blazers play, any big sort of sports arena. You compared to that arena is about the same as the Earth compared to the sun. And I even ask the students, I'm like, go up to the stadium and give it one of those. How much did you influence that stadium? Exactly the same amount that the Earth can influence the sun. We're so small compared to the sun that we have no influence whatsoever over that body. And look, here's just a couple fun things. Don't worry about this so much, but I do think this is kind of neat. That there's no surface of the sun. I got the air quotes, there's no surface. But when we see the sun that looks like this, we perceive a surface. And that's called the photosphere. I promise, no pop. There is a pop quiz, but not about that. Get back there. Use my batteries are dying. And look, I just think it's kind of a neat thing that the surface of the sun is about 6,000 degrees Fahrenheit. 20 times hotter than your oven when we're baking something for dinner or something like that. So again, kind of things that are a little hard to grasp when you first learn about them, but neat stuff that tickles your brains anyways. We gotta remember one thing. The sun is a star. And by the way, it's a very special star because it's ours and we orbit around it. But our star, our sun, is just like any other star up in the sky. And I like to think right now, this very second, there is a Bizarro Dr. Fisher who's speaking in the Bizarro Bowman Museum in Bizarro, Prineville, on a planet around some other star. And when they go out in their sky tonight and look up, you know what our sun looks like? I know which one it is. It's that one. No, I'm just joking. I don't know which one. Oh, it's that one. Or it's this one. Or it's this one. Or it's that one. That's it. If we were on another planet looking back towards ours, we would blend into the background just like that. And that's again something to sort of ponder and something to think about. And that's going to be directly connected to this thing about exoplanets that I'm going to talk about here in a few minutes. But I like that as sort of again a moment to sort of realize that we don't think about it that much, but if there was somebody out there looking back at us, we would blend into the background just like they do. So remember the main point, don't look at the sun. Take a glance. Take a glance at the sun, but don't look at it. But next time you see it like this, take a peek and see if it might look a teeny bit different to you this time. You know, we look up in the sky and we see lots of different things. All this is a good one. So, and one of the things that we sort of have a hard time perceiving is that the sky is 3 dimensions. You know, that's a 3-dimensional sky that we're looking at. And by the way, sometimes you might look up in the sky and see 2 stars that are right next to you, but actually that's like that. You know, one of those stars is a lot closer. And this is a gentleman from Finland, it turns out. I read his webpage. JP Metsav, JP. And JP he's an astrophotographer, a computer scientist, and a pretty good artist. And this is a photograph he took of an object called a nebula. And all of the points of light you see are stars, and the nebula is a big cloud of gas, hydrogen gas and helium gas, that lives out between the stars. And what JP, he knew it's hard to see these images as 3D, so he did what I like to call a scientific Photoshop. This is not real data, but he did something very clever, and he figured out how to turn a picture like this into this. Yeah. Oh, I know. Well, golf clap for JP. Well done, JP. Just by making the image move back and forth, it tricks our brain into seeing the 3D. Look at these 3 little stars up here. They're in the front, right? There, the nebula is sort of in the middle, and look at these ones back in behind it. And by the way, it's a scientific Photoshop because JP went out and found the distances to some of those stars so he could make it look roughly what it would look like if we could see it in 3D. And by the way, the man's good. He did this one, and then let's have a moment of class participation. And by the way, you guys might not think it, but I make all 250 of them do this too. Get your hands out real quick, and make a bowl. Can you make a bowl with your hands? Now imagine that your palms are painted turquoise. This is what you're seeing. This is a bowl that's moving back and forth like this. And look at this little thumb right here. This is my thumb sticking out. See, kind of helps with the 3D. This is a star cluster. And in that cluster, there's a couple hundred stars. And those stars are giving off so much energy, it's actually carving this bowl in this massive nebula. And by the way, this nebula would stretch bigger than this whole museum. But the stars are giving us so much energy, we can see right there how they're affecting. And by the way, that's the material that the stars themselves formed out of. So that's the cradle that the stars formed out of. And that's just a good way that you can see. Well, one more JP, or I think you guys are right. Call it a globular cluster. Maybe he might have printed or plotted, that might be 1,000 stars. If for real, often these clusters will have 100,000, 200,000 stars in them. And all of those stars are orbiting around each other. I always think of it as a beehive. Oh, I think of the bees, flying around a beehive. And then that whole thing as a unit is orbiting around our Milky Way galaxy. And by the way, our Milky Way galaxy is about 200 of these clusters that orbit around the galaxy. But again, it's just a really neat way that JP has figured out how to let us see these objects in 3D. So well done, JP. You're the man, as the students say these days. All right, topic 2. We got our first perspective check. Earth is tiny compared to the sun. It turns out, yeah. And now, again, imagine you are so friendly. Now imagine 250 undergraduates. And I turn this up and I'm like, students, get ready for your, by the way, you'll notice a NASA shot glass. First of all, illegal. Thank you very much. Which I confiscated. No, I didn't. I was given it to me as a gift. Yeah, but so let us have a moment here. We're going to take the entire solar system and shrink it down to something that we can maybe wrap our brains around a little bit. And we're going to take that big old sun and we're going to shrink it down to the size of a large grapefruit. It turns out that grapefruits go bad. And they only last a couple weeks. And so the grapefruit, well, a student painted a softball for me to look like the sun. So let's imagine a medium-sized grapefruit. I should change it to the softball scale, but I can't because it was originally the grapefruit scale. And so look, we're going to take the sun and we're going to shrink it down to that size. Oh, you guys, you don't know. When's the last time you took a quiz? That's a good answer. Well, it turns out that you know what's really hard to do is put your hand up in front of people and ask a question. Or put your hand up and choose an answer. So tonight, I'm going to introduce you to what we call an active learning technique. We're going to do a chess vote. I'm going to give you a multiple choice question here in a second. And your job is to hold up what answer you think. I want you to hold your hand right here. 1, 2, 3, or 4. And the reason is I can see your answers, but nobody else can see your answers. And that makes it, and by the way, I thought this was sort of cute and funny at first. It works. Even in the big classroom, you can engage with them. And I'll tell you, when I do this in class, at least 3/4 of them take part. By the way, the last quarter's in the back row, they're watching they're surfing the web. I can't do anything about those kids. But lots of folks will take part. Are you ready? Question 1. If we shrunk the sun down to the size of this lovely softball, how big would the Earth be on this scale? Oh, do we have Jeopardy music? Make the Jeopardy sound. No, I'm just no. Oh, thank you, sir. He was one to do it. We got some. I see you guys are, we got a wide spread. I have 1s, we got some 2s. Oh, I see a 4. I see 2s, 4s. We got an Uno. It's 2. Oh, don't do that. Right? Think about that. Oh, I got one right here. Think of the ballpoint pen tip in like about 109. Oh my gosh. Let's not do that. What happened? Oh, there we go. Yeah, but imagine about 109 of these would fit across the front of that. Can I give you another sidebar? By the way, my students love when I say sidebar because I know Fisher's on a rant. This is not a rant, this is a cute story. In professor school, by the way, there's no such thing as professor school. They're just like, hi, Dr. Fisher, welcome to UO. You're teaching 200 students. Hi, students. And so the first time I did this in class, I didn't use a ballpoint pen tip. I said, number 2 was a BB. How many people in here know what a BB is? All of us. Of a certain age. You know who does not know what BBs are? College students today. And how did I learn this? Because I asked this one an exam, and it was a foreign student. I knew her from her handwriting, and she wrote, oh, if the sun is the size of a grapefruit, the earth is the size of a BB. And she put in parentheses, a baby bee. I'm like, oh my God, that's so cute. You got it right. But they obviously don't know what BBs are. So we had to switch it to ballpoint pen tip. So There you go. I thought you guys might get a kick out of that. Yeah. So no more meetings. Modern knowledge. That's it. What is that? Yeah, modern problems call for modern solutions. Thank you very much. Yes. Okay. Number 2. Bust you off this one. Sun, Earth, the size of a pen tip. How far away would the Earth be? And by the way, I know this is not fair, right? I'm not playing fair. You guys, but it's just sort of, it's more, I promise I'm not going to grade you on this one, yeah. We got 4s. We got 4s and 3s. Oh, I see. And by the way, what I do in class is I watch. And if I get one answer that's more prevalent than everybody else, that's good. But if there's a big, everybody's choosing everything, I'll actually make them turn to each other and speak to each other. It's hell, as you can imagine. But I make them talk to each other and try to come to some consensus. But we're actually doing pretty good. We got lots of 4s, lots of 3s. That's a bummer though, because it's 2. But that's still pretty interesting, right? Think if the sun were right here, oh gosh, Sean, where Sean is, that's not quite 50 feet, but this room is roughly 50 feet away. So the sun would be here, and the Earth would be a little pen tip orbiting back there in the corner of the room. And by the way, on this scale, the whole solar system, it would be about the size of downtown here. What downtown is, 10 blocks, by 10 blocks or something like that. Yeah, it's about the size of the UO campus, which must be similar to the size of downtown. So our whole solar system would be about the size of downtown on this scale. And I got one more for you, just another one. Same scale, the sun is right here in the middle of Prineville. How far would you have to go to our nearest star? Which, by the way, the name of that star is Alpha Centauri. But that's our neighbor, the neighbor right next door. If you need to borrow a cup of sugar, you're going over there to borrow it. What you think? You got guesses? It's a tough one. This third row is active, man. You guys are in there, like boom, first ones. 1, 2. Oh, we got good. Oh, we got a good spread. We got 4s. We got 2s. 2s and 4s are winning. Oh, we got 2 down low. You're being bold. Really? Look at this. 2,500 miles away. Cosmic perception check. And by the way, I'm going to just out myself a little bit, y'all, since being so friendly. I didn't know any of this, but I started teaching 101, right? My job was to sit in a control room in front of 8 monitors and work in a telescope. And I knew things about galaxies on the other side of the universe and how dust balls form and how planets form. But like this basic 101 stuff, this blew my mind when I started teaching. 2,500 miles away. Right? We got our beautiful little star right here. And by the way, our neighbor star is a glowing grapefruit on top of the Washington Monument. And I used to live in D.C., and by the way, I flew there and I flew back one day, and I literally was flying by the Washington Monument, like, my God, there's a glowing grapefruit down there. And then I'm flying the whole way to Eugene, and that's our neighbor star, the one that's next to us. And so, maybe tonight, actually it was getting clear out. I'll give you all a little homework. I think tonight you're going to be able to, when you go out, you're going to get to see some stars tonight. And here's a picture that a colleague of ours took up at Pine Mountain. It's one of our telescopes up at Pine Mountain. It's just a beautiful dark sky, nice dark summer sky night. And on a night like that, you can see about 2,000 stars with our naked eye in the northern hemisphere. By the way, 2,000 more if you're in the south. The ones that these are all our neighbors. These are the stars that are fairly close to us in the Milky Way. They're so close, we can actually see them as little points. You can't see the size of the stars, right? They're called unresolved, so they're just little point sources. But this is the thing. You go out tonight and you point up and you see any random star that you see in the sky, it's probably 10 to 100 times farther away than our neighbor star. And my gosh, if this is here and the neighbor is in Washington, D.C., I don't even know, what is 100 times farther away than Washington, D.C.? 100 trips back and forth to Washington, D.C., but just that scale again. And tonight you walk up, and by the way, if you're at the Prineville Reservoir, where it's damn dark, by the scientific term, you might even get to see a star that's 1,000 times farther away than our neighbor. But then all of those are pretty much in the neighborhood. And I think that's just, again, kind of this sort of neat sense of scale that we can kind of grasp after we think about this stuff for a while. And now that's the farthest out I want to take you. Now I want to bring you back in a little bit. That's one of those professor school things. It's like scare them and then reel them in again. No, not scare you, but look. Oh, anybody know what that is? My all-time favorite planet. And I'm not mad at Earth. Earth's a cute little planet. It's fifth on the list. But this is number one all the time. Saturn. A real live picture of Saturn and a view that we can never see from Earth. And the reason I can tell you that is you look at this backside, the backside of Saturn. By the way, there's the shadow of Saturn on the rings. So which way's the sun in this picture? Yeah, right. The sun's way, way up. The sun is in Redmond, that way. No, far. This was taken by a spacecraft called Cassini. And Cassini was actually orbiting around Saturn. By the way, golf clap for humans. We can build a machine as big as a school bus, put it on a rocket, and throw it all the way to Saturn. And then it gets there and spends 10 years orbiting around Saturn, learning the most wonderful things about the planet and its moons and those rings and all sorts of stuff. By the way, Cassini is Cassini. Right easy. You type Cassini in, boom, on your favorite Google, and it's the first hit. So this is, you know what? I'm feeling bold. This is the best picture of Saturn that was ever taken from Saturn. Okay, there's not that many of them. But this is the best one from a spacecraft right at Saturn. What if now I'm going to show you the best picture of Saturn ever taken from Earth. Saturn's not purple. This is true color. This is what Saturn actually looks like. And by the way, soft pitch, Alton, can you see Saturn from Pine Mountain? How well can you see it, sir?
Beautifully.
Really beautifully or just beautifully?
Well, not compared to the Cassini probe.
Why all have you? Bang, where's that back? Right in the kiss, right little bit of you sometimes. Look, this is what Saturn looks like. If we could fly there, this is what it would look like with our eyes. And by the way, the pitch is, come to Pine Mountain next summer, and we'll show you Saturn through our 24-inch telescope with your own eyes. Best picture of Saturn ever taken from Saturn. Best picture of Saturn. Oh my God, don't do that. Oh my poor dude there. Stop. Cool. The best picture of Saturn ever taken from Earth. This was taken by the Gemini Observatory when I didn't take it. Two colleagues, Henry and Emily, took this picture of Saturn. It's an infrared picture of Saturn, which is why we can paint it whatever color we wanted. And Emily and Henry, they painted Saturn purple and the rings pink to show that they are composed of very different things. Saturn, like the sun, is gaseous. You couldn't stand on Saturn if we went there. You know, it's hydrogen gas and helium gas and nitrogen gas and all the gases that you can think of. And the rings are tiny little dust particles and tiny little pieces of ice. And what we now understand is the rings were made when a moon of Saturn got too close to Saturn and the gravity of Saturn crushed the moon. And then over the last 100 million years or so, that moon has ground itself down into dust. And that's the rings that we see right there. And by the way, this is a moon of Saturn called Titan. And so this photograph was taken with that monster telescope, you know, the mirror as big as this room, fourth largest telescope in the world, with really, really high-tech equipment. And I can say with confidence that this is, if it's not the best one, it's number one or number two. The best picture that's ever been taken of Saturn from Earth. How would you like to see the best picture of Earth ever taken from Saturn? Are you ready? I don't think that you're ready. Yeah. So that's us. So there's the Earth. that was taken by Cassini. And look, we are some, well done humans. Not only do you take the school bus and throw it all the way to Saturn, you then track it, and you happen to know right when it's going to orbit around Saturn and point the camera back to Earth. And so, of course, they took a picture. And this is a bit of a moment, folks. By the way, were any of you on Earth in 2012? I think we all were. Sometimes with the students, I have to ask them. Like, he said, yeah, so you were? Jesus, okay, you know. But everybody in here, yeah. So you were on Earth in 20, you're in that picture. You're in that picture. Were you in the western part of the United States, or Australia, or Japan, or Alaska, or part of Canada in the summer of 2012? You were actually in that picture, because that's the part of Earth that was facing towards Saturn when we took that picture. But oh, it hurts and warms my heart at the same time to think that every human being that has ever lived, and every human being so far that is on that little spot, it's only 2 pixels. And it's our entire planet. Ooh, it's a moment. Yeah, you can see. And by the way, it turns out NASA did something neat with this. And this is a Wikipedia page. So if you go to Wikipedia and you type the day the Earth smiled, you're going to see this. It was July 19th, 2013. In the summer, right in the middle of the day. And that was when Cassini looked back and took the picture. And I know damn sure that one person in this room is in that photograph. Because I walked out in the middle of the quad on campus and looked up in the sky where I knew Saturn was and waited, and I looked around to make sure nobody, and then I didn't move. And so I waved, and I think maybe they got me. I'm not sure. I'm not 100% sure. But still, we got Saturn. And by the way, here's a neat thing. Folks then submitted pictures of them smiling at Saturn, and we made a big photo mosaic of it. But this is a really neat page to have a cup of tea and take a look at. All right, so look, let's see. Let's talk about these exoplanets for a couple minutes. Give me 10 minutes and I'll let you go. Here's the key sentence right there. An exoplanet is a planet that orbits around a star that is not the sun. Our sun's a star, we learned that earlier, just like all the other stars up in the sky. And in the last 20 years, 30 years, in the last 30 years or so, we've now discovered many, many planets around other stars. And this is really something when I'm talking to a group of 20-year-olds, and just in their lifetime, we've discovered these planets. I think it's a little more profound for us, because of course we lived and we didn't know they were up there. And now we know they're up there. And that's a big deal. And you might get, I'm going to stand over here so my battery works, but watch. Every term that I taught the class, look at the number. I'm going to go fast. I taught a lot. 54, 50, and you ready? Whoa, wait. Go, wait. There it is. And as of today, I look today, 5,528 planets we know around stars that are the sun. The sky is filthy with them. They're everywhere. And you know what freaks me out a little bit? They've been up there the whole time. We just didn't know they were up there. And now we know they're up there. And that is a profound change in our understanding of the universe. And even more so, our place in the universe. Look, when every one of you was in school, all of us were in school, even me, we knew the nine planets, and we didn't know if there was a single planet in the whole dang universe. And now we know, we have confirmed there's 5,500 of them. And by the way, now we've learned, we've detected enough of them that our friends that are computer astronomers can now start doing statistical analysis of the data. And the current idea is that basically every star in the sky has one planet around it. Now, some of them have none, and some of them have 8, and some of them, like us, have 14. By the way, in the end, it makes it all better. We actually have 14 planets now. We've got 8 major planets and 6 dwarf planets here in the solar system. So, in the end, I'm okay. You know, 9, we got 14 now. But almost every star in the sky has a planet around it. And that is truly, that is something that's, again, we'll have a beverage of your choice or two, and think about that. That's something. So look, it's not a picture, it's a drawing of what we think that our Milky Way galaxy looks like. And by the way, the only part of the galaxy we've searched for planets is that tiny little wedge. And we've already found 500 of them. And so, I tell the students, I made a bet with them. 250 of them in the room. I bet them $1, collectively $1. Not all $1. That in their lifetime, I bet them that in their lifetime, we will know of 50,000 planets around other stars. And that might be a gross underestimation. It might be 1 million planets they might know of by 50 years from now. So look, we've only searched a teeny tiny little bit of the galaxy. And let me do something quick. I'm talking too loud. Look, if you take our whole galaxy and shrink it down, the solar system. Now our whole solar system is the size of a quarter. Then the Milky Way galaxy would be as big as all of North America. By the way, I love this because it turns out right here where Eugene is, or Prineville for that matter, that's pretty much where we are in the Milky Way, so I just thought this was an interesting question. So think of a quarter in Eugene, Oregon, and the whole Milky Way is the size of North America. We have searched the size of Lane County, is all we've searched so far. By the way, I learned that Lane County is almost the exact size of Connecticut. So yeah, go Oregon. Our counties are as big as states. Yes, very strong rectangular state. You know. But that's it. We've only searched a teeny little fraction of the galaxy for these things, and we're finding 5,500 of them. We don't care about that. Oh, we care about this, and I'm going to show you a movie, then I'm going to play with it. Look, I believe this. I believe that the discovery of the exoplanets has completely changed our understanding of where we fit in the big scale of things. And this is, we should be proud. You know, look, I say it was this, I'm not picking on the students, but look, it was our generations were the ones that did this. Your generations built the Apollos and the things and the stuff that set my generation up to build Cassini and the machines that are finding these planets. And we should be damn proud of this. Look, I like to think about 1,000 years in the future sometimes. And 1,000 years from now, some student is going to go and look up the Encyclopedia Galactica. And they're going to take the little stick and stick it in their head and download, the whole thing. And you know what the 2000s are going to have? 2 paragraphs. By the way, if you go home and look at your Encyclopedia Britannica, look at the 1020s. Is that some war in Europe? I don't know what the hell's going on. But they got about 2 paragraphs. And you know what? I'm convinced one of our paragraphs are going to be, these are the humans that discovered the exoplanets. It's that big. That's going to be our legacy. And I'm going to show you a video right now that proves it. We are making the map that future humans will take to the stars. That's a good one. So hold now. At the big finale, they tell you in professor school, never leave PowerPoint, but I'm feeling froggy. Watch. It's 1 minute and 17 seconds. This is a picture of the entire sky. The northern hemisphere, the entire sky. Okay? And I'm going to talk through. I try not to, but I'm going to. Each clip is a new planet we discovered. And watch, they're going to start to appear. By the way, here's the year. Look at this. Watch right here. That's only chapter 6. satellite called Kepler. And that's the part of the sky that Kepler looked at. And Kepler found most of the exoplanets that we know of are in that area of the sky. By the way, that's that wedge that we saw on that other picture. About 4,000 of the 5,000 planets are just in that tiny little part of the sky where we looked really hard for them. And so if you imagine that we did that over the whole sky, we're finding them everywhere. And that's the moment that I want to leave you with. And that is that in our lives, the sky has completely changed. It's gone from a barren place that we did not think there was a single planet out there to now we know it is a garden that is absolutely chock full of planets. And that's it. Thank you very much. If I'm willing to stay around and do some Q&A, you guys are fun. Thanks for taking part of the quiz too. Thank you.
Dr. Fisher.
Yes.
Well, one question and one you might ask to the people that have iPads.
Yes, ma'am.
When we were at Timeout, we told my granddaughter there was a free app that you could put on your iPad to go out and look at the stars, but I don't, right off my bat, can't think of it.
You sure can. And by the way, if you have an iPhone or an iPad, there's a free app. I think it's called Sky Safari. And if you have an Android phone, what's the one good Android app? What's the one you have? Skyview. Skyview, yeah. And by the way, you don't need to even spend 99 cents. There's a free version, and it uses your GPS in your phone, and you take it out, and you see something in the sky, and you hold your phone in front of it, and it tells you what it is. So, look at all these amateur astronomers in this room right now. Yeah, so.
The other question
Oh,
I
yes,
have
ma'am.
is there a way to see the pictures that Primal Reservoir is taking?
There might be. So that camera takes one picture every minute, and then at the end of the night, it puts it into a time-lapse movie. I'll tell you, I'm sorry, I don't know off the top of right now, but if you go to Google and type dark sky Oregon, I think it's going to come up with our little groups, with just dark sky Oregon. And that might send you down the rabbit hole to find it. But if you see, they're beautiful movies, as you might imagine. Yes, sir.
5,000 exoplanets.
Yes.
How many of those, or what percentage of those, are potentially a climate that can sustain life?
That's a great question. So of those 5,000 planets, how many of them you might call are Earth-like, or could sustain? Because right now we're looking for life like us, and it's about 2%. So of those 5,000, there's 100 or so that are what we might think that are the correct distance from their star that there might be liquid water. And that's what we're looking for. When we say we're looking for life, we're looking for places where there might be liquid water. Because by the way, we're all 75%, very attractive water balloons, we all are. We're 75% water, so we're looking for places that have water. It's about 1 or 2% right now. And by the way, we know that because now we've discovered 5,500 of them, and we can start doing the math, the kind of statistical analysis and that sort of thing. Well, I saw somebody over here.
Who is this getting?
Oh, I keep picking on him. So this is Alton Lucan. Stand up, Alton. So Alton is the head of operations at Pine Mountain. So he and I are a two-man team. Yeah, look at
Don't get us both going.
No, my God, no. I think you are ready for it, but that's another half an hour. But Alton lives in Redmond. And he commutes more or less back and forth to the observatory, and then I'm over in Eugene. And by the way, Alton and we've done something really neat just last year. We got the internet upgraded out at Pine Mountain, and we can now sit in Eugene and observe with 2 of the telescopes up there. So it turns out that's quite nice for the executive staff. I get to sit in a nice warm control room in Eugene. Alton, what do you get to do?
Freeze out in the icy cold.
I know, so sad.
Out of sleep, waiting for the students to park the scopes.
Yes, and and it turns out that late night observing, that's a young person's job. Let me tell you that. Yeah, so the student's like, Dr. Fisher, can we go I'm going to bed at 2. Good luck, you know. But all gets to stay open. Yes?
I was just curious, the star that sparkles red,
Oh.
is that really, like I've heard rumors it's Mars. But is it-
Oh, well, Mars, I don't think we can see Mars right now. I don't think Mars is
But
up.
there's one, just one that sparkles red.
There are a handful of stars that have an orangish red color to them. And by the way, that's because they're fairly cool. The color of a star has to do with its temperature. If it's one of the brighter stars, it might be Betelgeuse. Don't say it 3 times. But Betelgeuse, I got what to say. Betelgeuse is part of Orion, and Orion is just starting to rise. You know what? By 10 o'clock or 11 o'clock, you might be able to see Orion. And if it's low in the sky, it'll twinkle, but that has to do with the Earth's atmosphere.